Okay, my name's Anetor Asibor, and this is my project for Physics 1 Professor Store's class, and that is the correct spelling of my name. University Physics 1 and for Professor Store. So today I'm going to be going over Newton's laws of motion. And completing two example problems with equations I'm going to derive from these three laws. Well, two of the laws. All right, so first let's go over the laws. I found this clip on NASA's website with a direct quote. And the first law: every object persists in its state of rest or uniform motion in a straight line unless it is compelled to change the state by forces impressed on it. Go ahead and write that down. Law 2: force is equal to the change in momentum per change in time for a constant mass. Force equals mass times acceleration. So we're definitely going to need that. Times acceleration. And also this third law: for every action, there's an equal and opposite reaction. So that'll come into play when we discuss our normal force for problem 2. So for problem 1, let's say I'm leaving Prairie View's campus and my Ford Focus runs out of gas. I want to push my car, which weighs 1,750 kilograms, with a constant acceleration of 0.05 meters per second squared to Buc-ee's to refill my gas. Assuming a perfect world with no friction, so there's no friction from the road on my tires or from my tires to the road to slow it down, how much how much force am I applying to my car to reach this acceleration? So using that equation we got from the second law, force equals mass times acceleration, my mass, 1,750 kilograms, times the acceleration I would like to get the car up to, 0.05 meters a second squared. Paying attention to our units and bringing those all the way through. Once we multiply, we're going to end up with 87.5 kilograms per meters a second squared, which comes out to a grand total of 87.5 newtons. My O's always look like an A. There we go. All right, that was our first question. Let's move on to something a little bit harder. All right, a 20 kilogram block is placed on a frictionless incline with the angle of 30 degrees with respect to X. The block is let go and begins to slide. What is its acceleration? All right, so to begin this problem, I always like to draw a quick diagram. Let's see. This is our 30-degree plane. (30 degrees) with respect to X, that flat ground. And let's just place this block right here. Okay, and it's going to slide down in this direction according to gravity. All right, to find that acceleration, we're going to use that second equation, force equals mass times acceleration, and we're just going to rearrange that. So I always like to draw my quick triangle, mass times acceleration, force, so I could derive that my acceleration is going to equal my force divided by my mass. All right, I'm just going to highlight my givens really quick. 20, 30 degrees, and what is the acceleration? Well, also frictionless incline. Okay, so looking at Newton's third law, to every action there's an equal and opposite reaction. We're going to know that perpendicular to this plane there's an opposite reaction, and that would be the normal force. All right, we would use that if we're looking for the resistance if there was friction, but in this case we're just going to draw a quick triangle, and that's straight down. My handwriting's pretty bad. To see what forces are acting on this object. All right, we're going to say this is a perfect 90-degree triangle, and this was a perfect 90-degree triangle. Looking at these triangles, you notice characteristics of a similar triangle, that these two angles are going to be the same. So this will also be 30 degrees. And we're trying to figure out the acceleration in this direction. So we're going to be looking at this side of that triangle. So that's going to be the forces acting on the object. And we know that according to gravity, this angle right here is going to be m times g, our mass times gravity. And using SOHCAHTOA, some trig identities to find this bottom side of this triangle, that angle in red. Looking at sine, opposite over hypotenuse, we have our hypotenuse, we have our theta at 30. We can come to the conclusion that mass times gravity equals sine theta. Okay. So we have our forces acting in the direction parallel to the plane right here. And since this block isn't coming off the block at all, or the block isn't coming off the incline at all, we can actually ignore this right here. All right, since there's no force saying it's lifting off or it's being repelled from that plane, we're just going to ignore that. And input for our equation. So we're looking for that acceleration, and that force would be the net force in this direction. So this net force is only happening at this angle right here. So we have, let's get to the same color, mass times gravity times sine of theta divided by our mass. And we're just going to cancel that out, because since there's no friction at all, our mass actually doesn't matter. So it doesn't matter if that block was 200 kilograms or 0.05 kilograms. The acceleration would be the same on a frictionless surface. So we're just going to input for what we know. We know our gravity is 9.8 meters a second squared. And we know sine of 30 degrees is 1/2. So 9.8 divided by 2 equals 4.9 meters a second squared. And that's our acceleration. And we can just look up here, make sure our units all carry through. That should be easy because it's just gravity. That's our acceleration going down. Perfect. And that's my project. Again, my name's Anetor Asibor. This has been a project for Physics 1, going over Newton's 3 laws of motion, specifically 2 and 3, to solve 2 simple problems. And this PDF will be available through my Google Drive. Thank you and have a nice day.